Bismillahirrahmanirrahim. We are talking about the Mendelian disorder. Mendelian disorders. What is Mendelian disorder? The Mendelian disorder is a disorder that results from alteration involving a single gene. There is alteration in the single gene mutation occurs in the Mendelian disorder. Single gene mutation occurs in Mendelian disorder. Single gene mutation. This genetic defect may lead to the formation of abnormal protein or a reduction in the output of the gene product. This leads to abnormal protein formation, or they reduce the output product. Mechanism that this gene disorder include enzyme defects and their consequences. There may be enzyme defects and the consequences of this enzyme defects. There may be defects in the membrane receptor and transport system. Defects in the membrane receptor. There may be defects in the membrane receptors and transport protein, and there may be alteration in the structure, function, or quality of the receptor or enzymes. There may be alteration in the structure. Structure is ability. Alteration in the structure. Alteration in the structure. There may be alteration in the structure or alteration in the enzyme. This mutation resulting in the unusual reaction to the drugs. This may be results to unusual reaction to the drug. Example: G6PD deficiency. G6PD deficiency. So we are talking about the Mendelian disorder. Mendelian disorder are a group of disorder in which there is single gene mutation occur. There may be abnormal protein accumulates or decrease the output of product, and there may be enzyme defects in the structure of enzyme. There may be defects or there may be a full enzyme defects. There may be membrane receptors protein or membrane receptor enzyme defects. There may be alteration in the structure of the enzyme or protein, and there may be the unusual reaction to a specific drug. That is, example is G6PD deficiency reaction to a specific antimalarial drug. There is red cell hemolysis occur. Number first, we discussed the enzyme defects and their consequences. The enzyme defects and their consequences. The enzyme defects. What occur in the enzyme defects? Mutation may result in the synthesis of an enzyme which reduce the activity or reduce the amount of normal enzyme. When mutation occur in this enzyme, this is the enzyme. When mutation occur in this enzyme, that result of decrease the output. They decrease the output of this enzyme. Or they occur the intracellular accumulation of product. For example, this enzyme, this is E is the enzyme, and E convert to E1, E1 convert into E2, and E2 convert into E3. If there is the E2 deficiency, E2 enzyme deficiency occur, E3 cannot be synthesized. There is decreased output for E3 and increase the accumulation of E2 because the E2 cannot convert it into E3. There is the increased accumulation of E2. Increase the accumulation of E2. So the E2 is accumulate in this site. If there is the E enzyme deficiency, so this process cannot take place and the output is reduced and the process cannot be started. This is the due to mutation. This is also due to mutation, and if this occurs also due to mutation in a single gene. If the A2 cannot be converted into A3, there is enzyme A2 deficiency occur. So if the A2 cannot be converted into A3 and A2 mutation if occur in the A2, so in this case the E1 accumulates. In this case the E1 accumulates. The E1 accumulation occur. If this E1 is toxic to the tissue injury also occur. Tissue injury also occur if this is toxic, and decrease the output of the enzyme can also occur. And the intermediate substrate accumulation also occur because there is E1 is functioning into E2. E is functioning into E1 and E1 is not converted into A2. So when there is one enzyme deficiency in this state, if there is the enzyme deficiency, so the whole process cannot be take place and there is decrease in the output. If there is E1 deficiency, so the E1 cannot be converted into A2. The decreased output of product occur and there is E1 accumulation. If there is E1 is normal and E1 is converted into A2 and A3 mutation occur in if so the E2 accumulates. In this case the E2 accumulates. So if this is toxic to the tissue, they may cause the tissue injury and A3 output decrease. So this was about the enzyme defects. This was about the enzyme defects. We are discussing a few examples about the enzyme defects. For example, there is galactosemia, the deficiency of glucose 1-phosphate uridyl transferase. This leads to the accumulation of glucose. This leads to accumulation of not glucose, galactose, and consequent tissue damage occur. We are discussing a few examples of the enzyme defects and the intercellular and intermediate product accumulation. For example, if there is deficiency in the galactosemia, in galactosemia, there is an enzyme deficiency. This enzyme is called galactose 1-phosphate uridyl transferase. Galactose 1-phosphate uridyl transferase. Galactose 1-phosphate uridyl transferase. Uridyl transferase. If this enzyme deficiency occur, so the accumulation of galactose occur and the consequent the tissue damage also occur. In this enzyme deficiency, that is galactose 1-phosphate uridyl transferase, this occur in the galactosemia disease, and in this disorder there is accumulation of galactose. There is a accumulation of galactose, and this galactose leads to tissue injury. It damages the tissue. This galactose is toxic and it damages the tissue. We are discussing another examples for this intermediate accumulation. When there is excessive accumulation of complex substrates within the lysosome as a result of deficiency of the degradative enzyme, is responsible for a group of disease generally called lysosomal storage disease. What occurs in lysosomal storage disease? Lysosomal storage disease. In the lysosomal storage disease, the excessive accumulation of complex substrates occur within the lysosome. There is excessive accumulation of substrate. Accumulation of substrate occur within the lysosome. And this causes the lysosomal injury, and this is toxic. So in the lysosomal storage disease, the accumulation of the substrates, intermediate product of the enzyme, are accumulated in the lysosome, so they are called lysosomal storage disease because it stores the intermediate product of the enzyme, and its this enzymes intracellular within the lysosome. This product accumulate in the lysosome and they damage the lysosome. So this is called the lysosomal storage disease. For normal enzyme, the end product may be necessary for normal function. For example, if there is melanin deficiency from the lack of tyrosinase, the melanin cannot be synthesized and the condition is called albinism. Sometimes the end product of the enzyme is also necessary, for example in the albinism. Albinism patient is whitish in color. There is deficiency of melanin because of there is mutation in the enzyme called tyrosinase. When the mutation occurs in the tyrosinase, the melanin synthesis cannot be take place and the patient be without melanin, and this condition is called albinism. The patient is whitish in color. And sometimes failure to inactivate after should image substrate is bestly required. Sometimes there is an enzyme required that is called alpha-1 antitrypsin. The alpha-1 antitrypsins inactivate the tissue, the neutrophil elastasis. This inactivate the neutrophil elastasis. What the neutrophil elastasis do? The neutrophil elastasis kill the alveoli. And sometimes there is alpha-1 antitrypsin deficiency. In the alpha-1 antitrypsin deficiency, there has been no activation of the neutrophil elastasis, and the neutrophil elastasis take advantage from this deficiency of the alpha-1 antitrypsins and they kill the alveoli. There is alveolar damage. Normally, the alpha-1 antitrypsins work and inactivate the neutrophil elastasis, and they prevent the neutrophil elastasis from killing the alveoli. When this alpha-1 antitrypsin deficiency occurs, the neutrophil elastasis will attack on the alveoli and the alveolar damage occur. And destruction of the elastin in the walls of the lung alveoli occur. They destruct the alveolar wall, especially elastin. They damage the alveolar elastin, and this results into pulmonary emphysema. What is pulmonary emphysema? In pulmonary emphysema, due to alpha-1 antitrypsin deficiency, there is mutation in the alpha-1 antitrypsin deficiency. There is mutation in the alpha-1 antitrypsin, and the alpha-1 antitrypsin deficiency occur. And the alpha-1 antitrypsin deficiency occur due to mutation in the alpha-1 antitrypsin genes. So there is no inactivation of the neutrophil elastasis, and the neutrophil elastasis will kill the alveoli elastin. They attack on the elastin of the alveoli and alveolar damage occur, and this leads to a condition called pulmonary emphysema due to alpha-1 antitrypsin deficiency. The alpha-1 antitrypsin deficiency occur due to mutation in the alpha-1 antitrypsin genes. Now we will discuss about the familial hypercholesterolemia. In the familial hypercholesterolemia, there is reduced the synthesis or function of LDL receptor. In this familial hypercholesterolemia, there is reduced the synthesis or function of the LDL receptors. In the familial hypercholesterolemia, they reduce the synthesis or function of LDL receptor. That leads to a defective transport of LDL into the cell, and secondary to excessive cholesterol synthesis by complex intermedullary mechanism also occur. In the familial hypercholesterolemia, there is reduced the synthesis of LDL or reduce the function of LDL. This LDL synthesis and function is reduced. As a result of this reduction in the function of LDL or the structure of LDL damage, that leads to defective transport of LDL into the cells. That leads to defective transport of the LDL into the cells. There is defective transport of LDL into the cells, and there is excessive accumulations of the cholesterol occur. So when this LDL is not transported into the cell, there is defective of this transport into the cell, so the LDL accumulates. So the cholesterol accumulates. The function of LDL is to carry this cholesterol into the cells and other tissues. When the LDL receptor function is reduced, or when LDL receptor number are reduced, so there is defective transport of LDL into the cells. So there is cholesterol accumulates. Cholesterol accumulates, and the cholesterol in the blood increases. This condition is called familial hypercholesterolemia. This is due to the familial condition, and there is mutation in the LDL receptor. There is mutation in the LDL receptor. Mutation. There is mutation in the LDL receptor, and the LDL receptor function and number are reduced, and there is defective transport of the LDL to carry this cholesterol into the cells and other tissues, and this cholesterol accumulates in the blood, and this is called familial hypercholesterolemia.